So we went through this first part. It talked about the different types. It talked about why they don't like um, the combination side of the whole municipal part of it, being that it has to be treated differently. It costs a little bit more money. I think we ended up here at manholes. So manholes are supposed to be located at intervals of 300 feet or less. Unfortunately, this is not always the case. And we've encountered numerous manholes 500 to 600 feet apart. Whenever there is a change of direction, you will find a manhole in a municipal sewer. In reality, manholes are straight runs when cleaning. Municipal sewers with high velocity water jet, the upstream manhole is located and pipe is cleaned from the lower manhole to the higher manhole. And we'll get into those techniques later in the book. So the two most significant problems a municipality must handle in the sanitary sewer systems are infiltration problems and inflow problems. So I guess the term is used as I and I. I's are for the infiltration and inflow. So infiltration, groundwater entering or infiltrating into a sanitary sewer. That's what we'd call infiltration on a sewer line. It's when the groundwater soaks into the pipe through the cracks, breaks or loose fitting joints. Infiltration creates the same problem that combination sewer creates. Once the groundwater enters the sanitary sewer, it is transported to a wastewater treatment plant and must be handled. Costs are involved. So we've all seen where there's this weird leak going on at one of the seams in the sewer line. And me and Ken and the lining crew here, we encountered a pretty severe infiltration problem here at one of the hotels, the big hotels here. Is they were getting this tons of water through this crack in the pipe, and it was groundwater. We tested the water. We sent it over to the college. They were able to test it, and they were able to ID the water being, but what did they find in that water, Ken?
They found that it was didn't have salt in it. So the assumption was it was from a spring, and so the infiltration came in through a fracture in the pipe, and then it was just flooding their system. So I'm not quite sure how they found it actually to even be to begin this conversation. I'm not sure how they found it. I don't know if somebody ran a camera or they, and how that all came about, but it was entering through that fracture, but it was like a spring that was near the fracture of the pipe, and it was a lot of water.
Yeah, I think I might have that. Give me 1 second. I think I might have that video here, just to kind of show you guys what we were seeing. Yeah, here's real quick. So this is the job we were looking at in Lahaina.
Yeah, there's flow from the.
See how much water we were getting in that seam?
It's pretty clean.
This wasn't a
That's
broken
flow
water
from the
line,
other
but
side.
we have our camera in the drain. And this
The
is what
big
we were
one
seeing.
is
This is a tie-in
It's
we're
a,
looking up right now.
yeah, it's an 8-inch pipe.
she wanted a sample from sewer, so I was just
And we were only about 4 feet in. This the footage on there is not right. And this was a 6 to 8 inch drain. We were just trying to look up this tie-in right here because we were planning a way of trying to deal with this.
so we see your channel.
But you could see the amount of water that we were getting in that sewer drain there. I mean, it was for an 8 inch drain. That's a lot of water
from the tie-in.
I'm not sure if we got a straight picture of it, but oh, here you can see the crack in the pipe on the top right. And that was just straight groundwater. And then
That's me on the top left.
oh, this one.
No, the middle.
Oh, no, this one right there. Anyway, so the repair we did was we shot a liner through it.
Okay, go ahead.
And it stopped. We were able to
So this is that tie-in. Back up. Back up. Back up. Right there.
this is the tie-in that was there before. This is where we were getting the water infiltration before. Smooth transition with the 8 inch. And that's the manhole.
Josh, so you guys were able to shoot that liner with that infiltration?
Oh yeah. So that was a concern we were having too, is we asked a bunch of questions about, is this gonna, fuck us up or, stuff like that. So yeah, and what we did, instead of shooting it with our inversion gun, we ended up, because it was only like how far was it? 12, 15 feet? No, it was
It was
20 feet, huh?
It was a 30-foot shot. I would say 12, no, about 20 feet of it was 6-inch, and then the balance was 8, because it went where that tie-in and where it ended up as an 8-inch line. So we had to make that transition because we couldn't stop short of that tie-in.
Yeah, and Steve had ordered a special type of liner to where it could stretch from 6 to 8.
So
So
we pre-lined that shorter section. I mean,
Yeah.
the 6-inch section.
yeah, so what we did is we shot everything outside dry. We then we wet it out on the tables, and then we pulled the pre-liner over the liner. We used the tape and everything to get it all as I said, we pulled it through instead of trying to invert it because of the angle we had to get down the sample box we were working out of was kind of tough, but we were able to pull it through. We blew it up, and yeah, that was the the whole procedure.
Nice.
Yeah,
So
so
the
it came out nice.
pre-liner is what saved you from any washout.
Yeah.
Nice.
Yeah.
It came out really good too.
Yeah.
Thanks.
Josh, we didn't use water to invert. Did we use water
No,
or just air?
we ambient because oh no, we did water cure.
Yeah, we did water cure.
We did
yeah.
water cure. Yeah.
Yeah, that's right. Because we had 2 openings. I think we did a water cure. In the beginning, when we inflated, it blew out, and so we had to. What did we do? You ended up shooting another cow in there, yeah? Or we just pulled back the cow and we had to. Oh, wait, we had to fish the old cow out. That
Yeah.
shit fell in the manhole.
Yeah.
Yeah. So the first install was a little tricky. There was a little bit of a problem, but ended up saving it. Typical liner job. Nothing goes as planned, right? So you got to just be prepared for the absolute worst.
Yeah, but we
Main
like that
thing,
kind
the
of
end
stuff.
result was good.
Yeah,
End result was
yeah.
great. Yeah, very fortunate on that.
We like the challenges. So yeah, that's just an example of the infiltration. Let's get back in the book. So we're talking about the ionize. Lord have mercy. The 2 eyes are the first one. For infiltration, where infiltration is groundwater entering or infiltrating into the sewer system. The groundwater soaks into the pipe through cracks, breaks, or loose fitting joints. Infiltration creates the same problem as a combination sewer creates. Once the groundwater enters the sewer, sanitary sewer is transported to the wastewater plant and must be handled. So that is the infiltration part of that term right there. And then we move on to what they call is an inflow. So I mentioned earlier that there should be a separate sanitary sewer and a storm sewer system. The reason is the wastewater plant do not want to treat stormwater. If an inflow problem exists, then the treatment plant is treating stormwater. Inflow is an illegal tap of downspouts or other point sources into sanitary sewers. Whenever it rains, the stormwater is collected and runs into sanitary sewers. City employees working in the sanitation department oftentimes perform smoke testing to locate both inflow problems and some types of infiltration problems. Smoke testing is performed by placing a smoke bomb in the municipal sewer through manhole and blowing air so the smoke will pass through the municipal sewer. Smoke may come up through cracks or breaks in the pipe. If there is an inflow problem, smoke will billow up through the downspout and out other point sources. The property owner is given notice and possibly a citation for an illegal tap into the sanitary sewer. The tap must be removed within a specific period of time. So the infiltration is talking about groundwater getting into to a broken area or a crack in the pipe. And the inflow side is when it's illegally tied into the sewer system. So people tying in their gutter drains or even condensation drains, stuff like that. That's all illegal tie-ins. That would be called an inflow type of deal there. And then they do, I guess they do run smoke tests to where if they're getting too much of something going on, they'll run smoke tests and they'll be able to tell if, people are illegally tied in or commercial properties are illegal tied in, because that smoke will come up from wherever, it can escape through. And if they find it through your storm system, then I guess people can get fined or cited for that. So now we're going to get into pipe materials used in municipal sewers. Keep in mind that the type of pipe selected for sanitary sewers varies according to the intended use. abrasions, characteristics, installation requirements, physical properties, handling requirements, and of course, cost effectiveness. Specific applications are reviewed before a certain pipe material is specified. There are two general classifications of sanitary sewer pipes: rigid pipe and flexible pipe. Rigid pipe is inherently stronger than flexible pipe. Flexible pipe draws much of its strength from the support in the soil which it is laid. So me and Ken were kind of talking about this yesterday, and so these are the rigid side of piping or sanitary piping that's used. So number one is vitrified. Is that how you say it? Vitrified clay pipe, or VSP, is manufactured from clay and shale. The word, they're gonna make me say it again. Vitrified means to change to a glass-like substance. Vitrified pipe is resistant to chemical corrosion and abrasion. It is used for gravity sewers only. So we've all seen this. It's that orange type of pipe. It's clay. Not sure if they make any other colors of it, but that's all we see here. Do you guys see a different color clay? No? You seen any, Ken? Darren? No?
Nope.
So that's that orange looking pipe, and they're brought together with it's a gasket, in the bells.
So they went from cement around the bells to a rubber gasket as time went on. In the beginning, when they first started, I think they were like 3-foot sections. They had no real way to seal it. So they were just pouring concrete around the bells. And then that moved to rubber kind of slip in, push in style gasket. Kind of what you see now on like SDR or C900.
Yeah, and I think the concrete before was I mean, I still see concrete today on rubber gasket fittings because of now they're getting, roots are able to get in, and we see roots all the time at every single joint of a clay pipe. And I think clay pipe comes at a different length. Is it 10-foot lengths on clay? 20?
I think it's shorter. It's like 5 and 3 because it's heavy.
Yeah. So moving on to number 2, cast iron pipe or gray iron is used for both gravity and pressure sanitary systems. And advantages include long laying lengths of high pressure and load bearing capabilities. It is, however, subject to corrosion and chemical attack. Is heavy and is subject to breakage in improper bedding. So we all seen cast iron pipe. We know the ups and downs of it. I mean, we know it can last forever. I mean, not forever, but it can last a long time. We've seen this stuff in the ground. We're digging it up, some of them 50 years later. So we know that it's got a pretty good lifespan to it. But we all know ultimately plastic is the way to get it out of there. So they usually use cast iron pipe nowadays as an insulated drain line, to where you can run it upstairs, overhead, and it kind of takes away the sound of water moving in your pipe. I'm sure we've all been someplace to where we're sitting down and downstairs, and we hear water moving above us, or for somebody flushing the toilet. That's because the upstairs is probably not piped in cast iron, so they use that overhead as just so it's quiet when water's moving around up there. These are put together in bands. They used to do lead and oakum. These come in 10-foot lengths. And then number 3, concrete pipe. There are 4 types of concrete pipe available. Reinforced concrete pipe, which is for gravity sewer lines only. Non-reinforced concrete pipe, which is gravity sewers only. Reinforced concrete pressure pipe, which is made for gravity and pressure, and pre-stressed concrete pressure pipe used for gravity and pressure. Pretty much the same way clay is put together. It's all Bell. I think that they do still concrete those joints. Yeah. And then I'm sure we've all seen this asbestos cement pipe, which is the ACP pipe. It is produced from asbestos fiber and cement. It is manufactured for both gravity, pressure sanitary sewers. And then, of course, the EPA is concerned with the pipe because of dangers of asbestos. So dealing with asbestos pipe is dangerous. We all know that. So when you do dig up a sewer line that is asbestos, a lot of guys get very they get very afraid of how I'm trying to deal with it. Is so my way of dealing with it is just soak that thing with water, because it's the dust that the asbestos the plumes of dust that you get from asbestos pipe is what's dangerous for you. The breathing, you breathe those fibers in or whatever. But just soak that pipe down as you're dealing with it, and try and keep that dust down from that pipe. And even when cutting into that drain, we use a wet target saw. You don't want to beat on there with your grinder. It is electric or battery, and you want to have some kind of water moving as you're cutting through that pipe. So we use our target saw with the water and everything, so that everybody say, of course, with a mask. And that's one way we deal with it here. You had something to say, Ken?
Yeah, so supposedly when you confront an asbestos pipe, you're actually not supposed to touch it. You really shouldn't be messing with it. But there are times where we as plumbers have to make repairs regardless. And I shouldn't say it like that. And safety should be always first. But there are proper ways of handling it. If you hired somebody to properly handle it, as Josh said, water is actually your best friend when it comes to it, because it's the dust and the fiber and the dust that actually is the problem. And of course, a respirator. Asbestos is actually very easy to deal with when airborne. It's when you're in a confined space and you're breathing it over a long period of time. I'm not saying it's good, to breathe a little. I'm not saying that at all. I'm just saying it's not a hard thing to deal with. When cutting with water and with a respirator, and then properly dusting off, washing off prior to removing respirator, you're actually safe, dealing with it. But I think the process when instructing a customer, let's just say you're dealing with an asbestos sewer main, the proper procedure at the time would be to abandon the main. You could use one of our technologies, whether you're lining through it, you're going to dig next to it and install a new main. You could burst through it, because you're not in the area of cutting. You can cut back where the cast iron connects to it. You're not going to find asbestos under slab. You'll find cast iron 2 feet outside of the foundation, and the main will be what is asbestos. You'll never find asbestos tie-ins and fittings underneath a cement slab. So you could cut into the cast iron, shoot through the cast iron, dealing with the asbestos, leaving it intact in place, because a lot of times that asbestos pipe is still actually in really good shape. We deal with it at Kahumanu Shopping Center. They have it as a water main. They have a 6-inch asbestos water main that fails from time to time. And it was a pretty big deal that we had to deal with a while back. But, it is something that you have to contend with from, every once in a while. And you got to know how to deal with it when you have to deal with it. But properly, you're supposed to just abandon it and leave it in place.
Is there any questions anybody got? So Ken is right. When you do deal with stuff like that, it's always good to let somebody know that what you're dealing with, especially management or whoever is your supervisor on the job. It's just we run into. That's not the only place we're going to run into asbestos. There's asbestos in all kinds of things that were made back in the days. Asbestos was a very much used material back then. So it's all over the place. So I mean, that's not the only place where we can be exposed to it, but that is the area where we can be. Even, certain tiles we cut on the flooring, the glue that's used has asbestos in it. So you always have to be aware of, that stuff too. Don't just start going to town. Ask somebody, am I dealing with asbestos? And it's not too much in like, it's the glue type tile that you'd have to worry about, like in school, that white tile. I mean, I don't know if you guys young enough or see that kind of tile, but Ken probably saw it. Kane, that white tile. When you peel it up, it's got that yellow or that black glue under it. So just be aware, and just ask questions. And no questions are a dumb question. I mean, there are some dumb questions, but especially if it comes to your future in life, on your lifespan, it's always good to be. What's up, Ken?
Just on identification, it's kind of hard sometimes to ID what you're looking at too. So if it's something that you haven't seen before, and color is an important, I would say, sign. You guys are used to seeing certain things. I know on Oahu, you guys deal with Orangeburg a lot more than we do. That's another type of pipe that you can be mistaken for. But we did one time, and this is how I found out about Orangeburg. We were in Kaneohe, and we were jetting a main, and the line was just falling apart. And I don't know what the hell was going on. I thought it was ABS. And when we finally figured out what it was, I called Steve. He was like, "Dude, you're dealing with Orangeburg." And I don't know what the hell he was talking about. And so that's when I discovered it. This is a little bit back, but at the same time, understanding what you're dealing with is important. Ask, you guys on a while, ask Darren, ask anybody who's there who's been around. We have some asbestos pipe here in certain spots on Maui. It's very zone related, time related. Kaneohe area, because of the military, they used a lot of Orangeburg out there. You'll find some asbestos piping. I mean, Darren will probably know more than me where, all that stuff is. And, to understand, the zones and locations, of where things may be, in the ground, kind of helps, how to deal with the customer. And then education is important, so have the understanding of what you guys are dealing with, because, the job can go from a simple repair to a pipe replacement. And if something is not a code approved method anymore, then why are we trying to fix it? And that'd be the question. Why are you trying to make a repair to something that is no longer approved and no longer safe to work with? At that point, the customer should be educated, and they should be upgraded to something that's, modern to code.
Yeah, it's good we that asbestos came up, because it is something dangerous to work with, and we can all get educated, like Ken said, in dealing with that particular material. I mean, not only in piping but other areas also. And then takes us into flexible pipe. So I do not have the answer for ductile iron pipe, but this pipe is similar to cast iron, except cerium and magnesium is added prior to the casting process. It is used both for gravity and pressure sanitary sewers. An asphalt-like coating and polyethylene exterior wrapping are common. Linings are available, which include cement mortar with asphaltic coating, coal tar epoxies and polyethylene. So to me, ductile iron is a pretty solid ass pipe. When they were classifying it as a flexible pipe, I
Dude, I
tried.
can bend that. You cannot bend that pipe. What's the matter with you?
So I tried looking up the word ductile is another term of that they use for flexible. So that's a pretty tough pipe. I mean, we deal more with ductile iron here as a more of a main water line here on Maui. I'm not sure I don't think I've ever seen ductile iron as a drain line here on Maui. I don't know if Oahu's seen it, but we
I
all
think
know
for
what.
sewer ejection.
Hmm. Ah,
And I think when we discussed it, I think the flexible portion is expansion contraction. And it's very minimal, but it does have a property that can expand and contract. I think when we think flexible, we think of like PVC where it can move, left to right, and it has some form of flex, but I don't think it's quite the same way and measured the same way.
yeah, because we first talked about we thought they were talking about the flex in the bells that you can do, but I don't know where they came up with that. I mean, I can research it more. But the next one here is the steel pipe, which is rarely used these days for sanitary sewers. However, the specific is normally has the interior protective coating or lining like asbestos or I don't know what that is. Bituminous. Connie's laughing at me. It is lightweight and has long laying lengths. Look, Brandon R is laughing at because I know that guy knows that word. What is that word, Brandon R?
Well, I don't know. I just when you read it, I was thinking bit of melon.
But anyways, I'm assuming they're talking about like galvanized pipe in that section. That's pretty much what we deal with here. And then moving on to number 3, thermoplastic pipe. The pipe includes a variety of plastics that can be softened by heating and hardened by cooling repeatedly. There are 4 types of thermoplastic pipe. The acrylonitrile styrene, which is ABS. ABS composite pipe, which is a filler such as cement. A filler such as cement is used in this type of pipe. The polyethylene pipe, which is the PE pipe, and the polyvinyl chloride pipe, the PVC. Thermoset plastic pipe. Unlike thermoplastic pipe, once thermoset plastic pipe is cured by heat, it cannot be refused, meaning it can't be reconnected. So keep in mind, sanitary sewers are designed to transport wastewater to the wastewater treatment plant for handling and disposal. In most cases, sanitary sewers are designed to work on gravity flow. Water runs downhill. Fortunately, it is not always possible for sanitary sewers to run down here to a wastewater treatment plant. Sometimes topography will prevent this natural occurrence. How do you get water to go uphill? The answer is, of course, is by using a pumping station or a lift station. Pumping stations are large lift stations. The intent of the station is to lift the water up to a point where gravity can once more be used to transport the wastewater to be given to a given point. A forced main will pump wastewater. The stations performed the same function as a sump pump in a residence, but on a much larger scale. So we've all dealt with that. Lift stations, big, small, commercial, residential. It's, we all know its purpose. It's used to get water to an area to where it can be, to where it's a gravity flow and out from there. Once wastewater reaches a wastewater treatment plant, it goes through many stages of treatment before the water is returned to the environment. There are different types of treatment plants, but it is not necessary to discuss this in detail. The key to the proper functioning of a treatment plant is to keep certain types of bacteria alive while they perform certain functions. The 2 main types of bacteria in wastewater treatment plants are aerobic and anaerobic bacteria anaerobic bacteria. Aerobic bacteria operates in the presence of oxygen, and anaerobic bacteria operates in the absence of oxygen. Fluctuative bacteria, a third type, can live. Facultative bacteria, a third type, can live with or without oxygen. So before we move into that area, we are gonna hold it up right there before my tongue falls out. There's a lot of big words. But anyways, yeah, we're moving along. We are in chapter 4, so we are halfway there. We are at 7:47. Anybody got any questions? Man, I must be doing my job right. Uh-oh.
Good job.
Anyways, guys, thank you for being here. Happy Tuesdays. See you guys Thursday for Connie's meeting.
Thursday. This
Oh,
week, no
no,
Thursday, guys. No Thursday this week.
No Thursdays. We can sleep in
Thank you,
Thursday.
Josh.
Yeah.
Roger, everybody. Thank you, guys.
Thank you.
Shoots.
Thank you.